Hello and welcome to this short video about a subtlety in the definition of isotopes. So this table is a very similar table to one that appeared in a exam question for GCSE double over chemistry. It presents a table, as you can see, of some elements, and it's asking us to identify which two of these are isotopes. So it will help us to recall the definition of an isotope. And here's a definition from Wikipedia. Isotopes are two or more types of atoms that have the same atomic number and position in the periodic table, and that differ in nucleon numbers due to different numbers of neutrons in their nuclei. Okay, and let's look at an example. We'll pick hydrogen. So here we can see the three isotopes of hydrogen. This one's called protium, deuterium, and tritium. And we can see here from the atomic numbers 1, mass numbers 1. This one, atomic numbers 1, so there's one proton, but the mass number's 2, so there's also one neutron. Here we have 1 and 3, so this one has 1 proton and 2 neutrons. Now the thing that might be confusing is that when we look at the periodic table, if you look at the periodic table, you'll typically see hydrogen given as this one. And the confusing thing might be that we might not be used to referring to this as an isotope because it doesn't differ from what we are used to. But in fact, all three of these are the isotopes of hydrogen. So if we take that same logic to this question, you might erroneously think that B, if we look here, the ones that have the same number of protons are B and D. We might think that since D has the same number of protons, neutrons and electrons, that is the standard form of the element, and this one is an isotope of that element D. We might think B is an isotope of D and not realise D is actually also an isotope. So because these are the same element but they only differ by their neutrons, they are both isotopes of that element.